Who's the monkey that's got no shame? It's Andy. It's Andy. Who's the monkey that wants to play the face game? It's Andy. Yay, Andy. Da 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 do 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 do. Da 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 do do. All right. Da 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 do do do. Hey now. Da 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 do do. Mr. Kovacs class. It's Mr. Kovacs class. You might learn on time. It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. All right, students. If you're a B-Day kid, after you complete this part 1, you're going to go to the back of the room and you're going to do the part 2 from the other day where we're going to take DNA out of strawberries. So you're going to come to the back of the room. As soon as you finish part 1, you can come to the back of the room. I'll be there and I will help you with the materials and remind you of the directions. And your goal is to pull some DNA. And then when you finish that, you can do part 3. But today we're going to go back to the face game real quickly. I'm going to show you some things. Like, first of all, remember the rules of the face game? All right, this card. Tongue out. This card, fish face. This card, crazy psycho face. You always have 2 cards. Sometimes you got to do what both cards say. Like this would be tongue out and fish face at the same time. However, this card only shows up if there's nothing covering it up. This is a recessive allele. It only shows up if there's no dominant around. So if you got this combination, even though you have this crazy psycho face card, you don't make the crazy psycho face. That's just this. I guess in the business we'd say that you are carrying the allele for crazy psycho face, but you don't have the phenotype for it. You're carrying that allele, your tongue out. All right, so here, let's do a couple more practices. Ready? Which face? Which face? Which face? Now, if you get 2 different color cards, we have a word for that. That's called 2 different. If you have 2 of the same color cards, that's called 2 of the same. All right, now think about it. In real life, if these are supposed to represent genes and alleles for genes. So there's one gene, index card. It tells you how to make a face. Just like in real life, a gene would tell you how to make a protein, right? And in real life, genes are written in code, right? The DNA code. So where do the different flavors come from? They come from mutations. Like we can imagine that, right? Here's the code for tongue out. Maybe there was a time when there was only people on earth who were tongue out. But then somebody made a mistake while copying their genes in their gametes, like in an egg or sperm cell, and maybe just made 1 letter mistake, right? See how that could be, where's T, but instead it was a C. 1 letter mistake caused a big phenotype change. And as long as that's not deadly, it might stick. In fact, it might make your life better. Maybe people like fish faces better than tongue outs, right? And then let's see, maybe that gene mutated again, right? So it mutated 2 times. So now you get another version. It's all done by mutations, and they have to happen in the germ cells, in the eggs or the sperm, right? And that's where crazy psycho face, and probably crazy psycho face existed, but didn't show up till generations later when the descendants of the first crazy psycho face had children. Right? Didn't even know that face would exist. Isn't that weird? Does that make sense? Now, unfortunately, every once in a while you get mutations, right? Let's say if we mutated and mutated. Now we're 4 mutations from the original. This one, this white card, right? Sometimes those mutations are terrible to get. We call them lethal alleles, right? Or you can think of them as the allele of death. That is, if this shows up, you are not going to survive. Now, it's not surprising these don't show up that much because the people that inherit them don't survive. And if you don't survive, you're not likely to have that many children, right? Right? So let's say, here's mom. She is carrying the allele of death. She's not dead because she's got the lymphoma, right? And there's dad. He's also carrying the allele of death. He's not dead. He's fish face. He's dominant. But there is a chance, right, that mom gives this one and dad gives this one, and then that poor child never gets a chance to make a face. Here, I'll show you some examples of real life. We call them lethal alleles. All right, so lethal allele is where there's a chance that mom and dad will pass on a gene that results in a less than desirable phenotype, right? There's mom and dad aren't dead because they have dominant alleles to cover up the lethal allele, but they can pass it on. Lethal alleles are almost always recessive, right? So there's mom, there's dad. They can actually have 4 different combinations of babies. This one, this one, this one, and this one, and this one's bad. Right? This one is like you don't want to be born with that. Okay? Now, lethal alleles technically don't have to be super deadly. Sometimes they are right off the bat, like you don't even develop. But sometimes they would develop later. Like I imagine if you got this combination in the face game, you probably would, this combination, you'd probably make the crazy psycho face, but you probably wouldn't last very long. Right? Again, we call those folks who have one copy of the lethal allele, we call them carriers. Carriers, right? They don't express that allele, but they're carrying it, which means there's a chance they could pass it on to their offspring. Right? Only one combination, right? Let's see. Now, lethal alleles technically don't have to be deadly. Technically, like pattern baldness is caused by a lethal recessive allele. It's an allele that basically stops your ability to make hair cells, and it's late onset. That means it doesn't start right away, so you'll make hair as a child and then it'll eventually. But some are lethal right off the bat, like sickle cell. Let's look at sickle cell. Sickle cell is a mutation, lethal mutation, that causes little red to not be shaped normally, to be shaped like this crescent shape. And the reason that's a problem is if you have sickle cells, they're not as flexible, they can't carry as much oxygen, they have a different shape of their hemoglobin, and they get caught in blood vessels and cause clots a lot. So people who have sickle cells will often not be able to carry as much oxygen, and will often have pain associated with getting blood cells blocked. It's almost like if you've ever had like your foot fall asleep, or your foot falls asleep because the amount of blood you're like squishing an artery, so there's less blood, and then the nerve cells start to go, hey, we need blood, we need oxygen and food and stuff, right? So if you had sickle cell, that would just happen like automatically if you had sickle cells. Now, of course, you only get sickle cell if your parents are carrying the trait, and sickle cell is lethal. If you're born with 2 copies of it, all of your cells are sickle shaped, you can't transport oxygen, you do not survive very well. But if you get one of each, we call you a carrier, and you have the trait, that is, some of your cells are sickled and some are not, which means your life's fairly normal, but every once in a while you have these episodes of, we call them crises, of pain and or bleeding and that kind of, or not bleeding, and of pain and numbness and stuff like that. Okay? The only way you know if you have sickle trait is if you're tested for it or you have the symptoms. And then if you have sickle trait and your partner has sickle trait, you need to know that there's a chance your baby might inherit both the recessive lethal alleles. Now, what's really interesting to me, because you know me, I'm like into how evolution works. Sickle is most prevalent here in the tropical regions of Africa and in the tropical regions of India, of the Asia. Okay, but it's pretty prevalent too in tropical parts of South America, and even fairly prevalent in North America too. Now, why is that? And what we found is that sickle trait, as weird as it sounds, sickle trait makes you resistant to a disease called malaria, right? So if you get the total sickle cells, you're not going to survive. If you get the regular cells, you'll do great, but you will probably get malaria, and malaria might kill you. But if you have the combination, you can't get malaria, so you're more likely to survive. So it makes sense that sickle trait would show up more often in places where there's more malaria. Now in the United States, there's not a lot of malaria, but don't forget our history as a nation. There were a lot of people that were stolen from places where there was quite a bit of malaria and moved against their will to live in the United States. Yeah, in the United States, amongst our modern African-American population, there's a large percentage of sickle cell trait. That's because their ancestors were stolen from Africa in the slave trade. Okay, so it's an example of natural selection, right? This one's selected against, this one's selected against, this one's selected for, but only in certain parts of the world. Interesting. All right, so remember, if you're a B day today, you're going to do part 2. If you're an A day, you don't have a part 2. Or if you're remote, no part 2.